So hello everyone and welcome to our first meetup of the year for Android 254 and Kotlin Kenya. It's been quite a while since we last did our meetups, and yeah, we decided this year to kickstart the monthly meetups, that is Android 254 and Kotlin Kenya. Yeah, last year we didn't have like any meetup apart from the last one was in February. And then we had the pandemic, and then we had to pause a bit because we had there was quite a number of events that were happening, and we felt that it's good, maybe we give all the community members time to also attend the other events and so on and so on. But now we've officially started the meetups. We'll be holding them virtually, and when possible, we are also making plans to resume the physical meetups, and we'll communicate the details soon. Yes, so to begin with, we have our speaker application form. As you know, I shared this at the very start of the year, that is on January, on Telegram, Twitter, and also maybe those who are in the WhatsApp group. I shared the form. Here is the link. So we are accepting speakers. That is, if you want to speak on the meetups like this one, please feel free to submit your application. The topics can be Android or Kotlin. Yeah, and we do not discriminate. Whatever topic you have, whichever level you want to target, we are very open and we are not discriminating anyone. So please, guys, use this link. I'll copy the link and share it on the chat. Yeah, but feel free to submit your speaker application in case you even want like help on maybe what type of sessions to submit, or you want to maybe help on presenting, maybe you have never presented on any meetup before. We are very, very flexible. We can even just help you, and maybe you can get even a co-presenter. Yeah, we do that a lot just to help everyone. In case you want to kickstart your speaking maybe career or something of the sort. I'll share this link on the chat, so feel free to submit your session. And for those maybe who have already submitted, I'll also maybe, we are getting back to you. Even if we maybe delay, we usually make sure we respond to each and every submission. Yes, so after that, so what do we have in plan for 2021 in terms of Android 254 and Kotlin Kenya? So we have a lot, we have so many things planned, and this is just a highlight for maybe what we've planned. To begin with, as I've mentioned, we have the monthly meetups, which will be happening every third Saturday of the month. So this has been like our norm. Every third Saturday of the month since the community started, we usually have our meetups. And then, yeah, the meetups will be either virtual or physical, as I've mentioned also. We are also making plans on recording, since this one is also recorded, and also sharing them on maybe a YouTube channel. Also, the physical one, we are also maybe on the plans just to make sure that we have all the sessions recorded, both physical and virtual ones. One other thing on the list is we have like hackathons every like 2 months. So we have like the first meetup is this one, and then we'll have maybe a first hackathon maybe next month, and we'll be having like every 2 months. So this is just to encourage the community members to build applications and also gain skills from their peers. So we'll be having like that kind of every 2 months we are having hackathons. So be ready, have your maybe applications, and maybe it cannot be, we are not restricting it to maybe just like where you come like an idea which is that can work on the market. You can even have like an idea to showcase something on Compose or something on a new technology that you have learned, and maybe that is an idea that is very viable for a hackathon. And then on December, we'll be having like a community awards kind of a thing, just to close everything. And maybe just to like close the hackathon things, we'll be having like a community awards for, that is, we'll be selecting those apps that have been developed from within the community that is in Kenya, both Android 254 and Kotlin in Kenya, and giving awards for the most outstanding one and the ones that we feel that deserve that recognition. So guys, please prepare for this and also keep working on apps. We are not limited to Android apps because we have Kotlin for server side, Kotlin for backend, and so on and so on. So be prepared for the December award, and we'll have more details coming soon at the either end of this month or early next month. One other thing, we have like quarterly in-depth sessions nicknamed as quids. So what does this mean? We'll be maybe taking topics. Let's say, for instance, you'll be introduced to Compose today. We'll maybe take like a Compose workshop or a conference where we just focus in depth on Compose, from maybe how the language design and so on and so on. So this will be like in-depth sessions where you get to select one topic and then cover that topic in depth, more than like a 50-minute session or a 2-hour session. Yeah. In case you have maybe a topic that you find challenging, please feel free to maybe suggest so that we can maybe keep them in loop for these sessions. One other session, which is another great idea, it's like a showcase nights. So these are nights similar to the hackathons, but maybe in a different format. You'll be having like just a night where you showcase something that you've built or something that you've worked on before, or something, maybe it can be even an idea that you want maybe people to validate for you or maybe to give you feedback. So if in case you have built something awesome, this is for you. Please watch out for it. And the other one is the Android Bootcamp, and then just nicknamed as tabs. And so the bootcamp is all about upskilling. And this, we are targeting, maybe you might be starting out in Kotlin or in Android, or maybe also maybe trying to maybe advance your career, mostly in terms of skills. So we'll be having like boot camps, maybe where we have 3 months of intense training and intense covering of the topics, and where we get to also, you get to one-on-one sessions where you get to ask questions and so on and so on. And then we have speakers. So the first one, we'll be having speakers across Kenya and all Africa to begin with, as today all our speakers are from Kenya, but so on, we'll continue inviting speakers from different regions so that you can get like different perspectives and share knowledge across all the regions. Another one, we have Googlers. I think last year we had a session where we had some of the Googlers like Chet Hess gracing the event. We'll be having also GDs and maybe dev evangelists. And lastly, of course, you who are in the session. So this goes along the lines of the speaker form I mentioned. So in case you want to speak, please feel free. We do not discriminate at all. So when you look at the plans, maybe this is just a highlight. So you'll realize one thing, we are focusing more on quality and quality. So we want to have quality sessions, we want to have quality speakers, and we also want the community to have quality apps or quality products that they have built. So that is just a brief on our plans this year. And in case maybe you have maybe an idea that you want us to incorporate, as we said, we do not have like a chairman for the two communities, and we don't have like that structure where we say it's a must decisions to come from this person. So please feel free to give the suggestions, and maybe we'll be happy to incorporate them as we plan for the year, because we can plan maybe, but maybe you people require something different. Maybe you don't want hackathons, you want something else. So feel free to drop a chat. Maybe you can reach out to me, or maybe on either Telegram, or WhatsApp, or even Twitter. So I think that is a brief of the. So Before I introduce today's session, I will be maybe hosting the session. I'm Harun Wangereka. I'm an Android developer, and also I'm passionate about technical writing and maybe organizing a couple of communities here and there. So today's sessions, I'll not maybe take much time because we have very limited time. We'll be learning about Jetpack Compose and ML Kit. So Jetpack Compose, I think I'll not water down anything. I'll let the speakers maybe give the brief on the session. And then, yeah, the first speaker will be Ben Salcie. That is his Twitter handle. And he's an embedded Android system developer at Brainverse. And then second speaker, we have Oliver Muthomi. Again, that is his Twitter handle. He's passionate about programming and have a second heart loving Android. Yeah, that is maybe just a brief about him, but he'll introduce himself more. So Salcie, are you ready? I want to hand over to you. Unless we have any question about the plans or anything. Yeah, so having no question, I think Salcie, you can take over.
Oh, okay.
Yeah, let me make you, I'll stop sharing. And then give.
Okay. Yeah, so thank you, Harun. And it's a big pleasure to have me be part of this community. And I know we all of us learn from our community and we need to give back. So for me, my name is Ben Salcie, and as Harun had presented earlier, I'm a embedded systems Android developer at Brainverse Technologies. So what basically I do is to create mobile apps that interface with hardware to provide solutions to the existing problems. So one case example would be like to a water vending system whereby one will come and be served with water and then they can do the billing and everything using their mobile app. Yeah, so basically that's what I do. So in today's session, we'll be learning about machine learning for Android. This is for the person who really wants to get into machine learning the Android way. Of course, machine learning is wide, and for those who really want to dig deeper into it, we could go further and study more about it. But as of today, we'll be just getting started with machine learning for Android. And all of us need to know that today's technology relies mostly on the destructive technologies, and machine learning is one of them. And machine learning basically is a subset of artificial intelligence. So artificial intelligence, the big umbrella, then machine learning comes in. So machine learning itself really tries to study objects using your device and then tries to come up with informative decisions and information based on the algorithm that it has been given. So I'm not really intending to take too much of your time. We'll just do a simple overview of it, and then we'll do a very simple code of it, and then we'll test and give out suggestions, see if you can implement on your own, and then you can build up on it. Machine learning doesn't end over here. Machine learning can also still be done using Python because most of the case studies that have been done and are successful have been done with Python, Keras, TensorFlow, and NumPy. So today we're not going to go into those, but we're just going to use the Firebase ML kit, which is a really simple one that you can use in your application. And so if you want to go further deeper into it, you could go learn Python, Python for ML, and implement such like those, like deploying your custom models to the server and trying to come up with analytic information from it. So yeah, so I'll just start sharing my screen. Okay. Harun, could you see my screen?
Yes, I can see your screen.
Okay, thanks. So I'm assuming you guys, most of you at least have interacted with Android Studio. So I'll just throw in some quick links that will really help us to build up this thing very fast. So let me just paste them in the chat section. So this is just some of the links that we'll be using to help us to get to learn Firebase ML Kit, and also what is required, what should be done, and stuff like this. So below here, that's just the libraries that we'll be using in. We have the Firebase core, then we have the Firebase ML Vision, and then you have the Picasso. So this Picasso will help us to load an image from a URL, and then the anchor to ideally help us to run the UI thread, and also maybe give an alert. And then I have a meta tag over here. So this meta tag will help us to tell Firebase ML Kit locally, like what exactly do we want to get from ML. So as you can see over here, we have ML Vision, then dependencies, and then for the value, we have the text. So this text simply means we're going to detect text from an image. And then for the face, it simply means if you want to detect a number of faces in an image, you use this. And then you can also label objects on the photo that you've taken or an image that you loaded from a server. So we'll need this to just fast track our project. So if you guys can be able to access your PCs, then you can just create a new project. This is just a blank project that's already created, just to save on time. And then just empty, so nothing there much. And then for the resources also, there's nothing much. Okay, so the first thing that we'll do for us to be able to run Firebase ML Kit into a project is to add Firebase into a project. So that is simple. You just go to tools and then Firebase, and then you go and select Firebase ML Kit. So this will simply add Firebase to your project and allow you to use Firebase functionality in your project. So you just scroll downwards and then go to Firebase ML there. So once you're there, you go use ML Kit to recognize text, not because today we're just going to detect text on images. So you just say use ML to detect text from your images. So make sure you connect that, and then once it's connected successfully, because I did this already just to save on time. Once it's connected successfully, then you can go ahead and have your piece. Let me just paste them in the chat so that you guys can see that. Those. So those are the dependencies we'll be using. So you can copy those and then add them to your Gradle. I did that already. So we have this. I added this. So I added those. So we have the Firebase core. Then we have the ML Vision. Then we have the Picasso to help us load the images from a network. And then we have Anchor. Only those. So once you've added them into your application, we'll go into your manifest and then give the two permissions to access the internet, because obviously when we want to load an image, our model as of now, because normally for you to run a machine learning model, you need to have your model deployed somewhere on which now when you give it a subset of the data that you want it to analyze, it will fetch it directly from wherever it's deployed with the result. So for our case, we'll be giving it an image object, which will be like a layer on which the machine learning model will have to create an object on it and then extract the text from it. So we will need internet for this. And then we'll add this meta tag. The meta tag is on the chart that I've just sent you right now. It's here. So this meta tag will so when you put your application on Play Store, it will tell the application to download the model locally so that you'll be able to detect either your images locally on your device or to download the model online or to do it or using the cloud at real time and remotely. So you add those just before you go, you add the activity tags, should be outside. So you have the meta and then com.google.firebase.ml, .vision, then .dependencies. So then the value for that is text, face, and label. So in future, if you have another session, we'll cover about the face and labeling objects in Android. Cool. So once you set up those correctly, we can now start, we can go to this link, the console.cloud.google.com. So why we go to this place is because normally this is a build, it's a build service, but you can have a trial version of it. So if you want to have a trial for this, because it goes for a couple of number of days and months, you can subscribe to the Blaze option. So you can copy that and then go to it. It's already open there. So there. So you can see your free trial is waiting. You can activate that. The Explore Google products. You're being given free $300 to use that onto your machine learning. I mean, for every other Google services that is usually built. So for our case, we're going to use Vision API, because this Vision API is the one that is going to enable us to use Firebase image vision for machine learning. So you go into this, when you open that URL, you'll be taken to this Google Cloud platform. So you just search for Cloud Vision. Vision API. So there you go. It's called Cloud Vision API. So you click on that and then you activate it. So since mine is already activated, you will see, if you are trying it for the first time, you will see enable this API. So since it's already enabled for mine, you won't see that option because you can see API, it's already enabled. So once you enable this, you'll be able to run your models and make requests to the Google Cloud platform with your images and send a sample image there, or URL, and then Google will return to you a response which corresponds to the text that exists in the image. So yeah, after you set up your Google Cloud platform, you'll be ready to run your machine learning as normal, as usual, and give it an image object, and then it will be able to extract text from it. So we will now start by creating the layouts. The layout, where now we're just going to have a very simple, UI to enable us to enter some image URL onto the screen, and then we can be able to load an image into an image view from an online image library or any other place. And then we can have one button. The one button to help us to just detect the text on the image. So the first thing we'll do is just to have an edit text. Okay, so that's our edit text. And then we're going to have an image view to hold this image that will be loaded from a network. So let's say image view. That's going to be below the edit text. And then we're just going to have a button. So this button will have a text of detect. Yeah, so just as simple as that for now. So we're going to have those. So we're going to have those. Just a simple one where we can enter the image. Let me just so that you guys can see where we can enter the image URL there, and then we can have the image itself. Once it's loaded, we want to put it into the image view. Now, once we have the image view, we'll be converting that into a bitmap drawable. Now, the machine learning by Google Firebase ML Kit will help us to convert this this bitmap drawable into a machine learning model object. Now, this object now we can extract text from it, and we're going through it into kind of a loop. So we extract the first one as we go, which is sequential. So that's how we'll be doing it. So once you click on detect, it will go through the image and find any other text that's on it and display to us. So with that simple UI, let's go to our main activity. So let's say, so in this example, I'm not going to use data binding and all those. I'm just going to make it as simple as possible so you guys can understand it even better. And I'll give out the source code for this if the session is too fast, so that you guys can catch up later and be able to implement it in your local machine. So once we have those, we can now start our actual logic. So we want when you type in the URL and then you press done, it should be able to load into, using Picasso, can be able to load into the image view. So we're going to listen for any editor action changed on the edit text so that we can be able to detect any changes on the editor, then be able to load the image using Picasso. So we're going to do that using so on editor, set on editor action listener. So we're going to listen to it whenever we inputting in some text. So the view represents the view. We're going to use that for now. We just remain with the action ID and then the event as well. We're going to use that. So we're just going to check if the action ID is done, so that on your normal keyboard, you'll be presented with either search, done, or next, or any other thing. So we're just going to listen to done. Just make sure that when a person clicks on done, they can be able to load the image into the image view using the Picasso library. So we say if action ID equals to editor info dot action done. So we're just going to check if the keyboard action is done, then we do something on it. So by default, just say false to make sure an editor and click listener not interfere into our process. So after this, then we could be able to check if there's some text entered into it. So say URL equals to so if the URL is not empty, then you'll be able to go ahead and do the logic for detecting the text. So the first thing will be to tell Picasso. I'm using the old Picasso, so you change that to the new one. So we'll see this load. Then where are we loading to? We're loading the URL, then into the. So we're just loading the image into the so that the reason for why we're doing this is because you want to take this image object and convert it into an object in which the machine learning model from Firebase ML kit will be able to detect and be able to perform an algorithm onto it to detect some text. So once we have the image, we can create an instance of the detector from Firebase ML kit. So we say val detector equals to Firebase vision get instance dot vision text detector. So this we just create an instance on which we want to bound this image object into the Firebase ML vision, and then be able to go through it and detect any text on it. So after that, we create another variable. Let's call it image text equals to Firebase vision image dot from bitmap. And then, so what you're going to do is to cast this image that is already loaded into our image view into a bitmap drawable. So we're gonna say if the image this holder the drawable, then as bitmap drawable, then dot bitmap. So we're converting that into a bitmap. Just make sure that we have an object that Firebase can be able to create an object on which it can go through it and detect some text on it. So using this earlier variable that we created for detector, we're going to say detector dot detect image, and then we give it the image text that we created as a bitmap there. Then as usual, we can add on complete listener, just to ensure that we know if the process was complete, and then you can also add on failure listener to make sure that you can be able to know if there was an error that occurred within it. So once we have this, we have the results into the it over here. And then also on failure, we can have it there. So when something goes wrong, we can use Anchor to run on the UI thread. Then just display an alert to the user. So we say alert. And just say something went wrong. Let me show. So after that, now when everything goes on correctly, we need to create a dummy variable over there. So we say detected text. Detected text equals to, initially it should be that way, so that when we precedingly add more objects that we see and we find text on each, we'll be just appending to that. So we say each because we need to go through every instance that we find a text and then be able to run it into a loop and then be able to add it, append it to the detected text. So we say each.result, then .blocks. Then for each of these blocks, you should be able to get an object or an instance of a text. So once we get that, we say detected text plus equals. So we're just appending that to it. So we say each.text. Yeah, battery. So once we having this in place, it means we have now extracted all the text from this image and we're able to reuse it. So this text might be something that you'll want to do maybe arithmetic operation, maybe you want to do your data analytics, maybe you want to be taking the name of a company, the name of a logo, or any other item that you want. So this will be added into this detected text. So if you want to do your analytics, you might want to go through it, filter, and do any other operations that you want. But for me today, I'll just alert it on a dialog, and then you'll be able to show the text that was detected on it. So, so we're just going to say alert. Sorry, we're going to run this on the UI thread. So we say alert. Then we say, so we pass in the object of detected text. As of now it has some detected text on it. Let me say, let me show that. So with this, when you run your application, you should be able to add in some text into your edit text, and then using this detector object of the Firebase vision from ML kit that we just declared over there, you should be able to detect the image. And then what we're doing over here is just to create a bitmap drawable that will make Firebase Vision image library or ML kit to be able to detect the text within that image. And then as a bitmap, Firebase ML kit will be able to go through every aspect of that image and be able to come up with the result, which is now in form of every line with the block. So we go through the result and then through the block. Then for each of the lines that you go through, you should be able to find some text on it, and then we just appending to the detected text, and then we're alerting it to the user. So let's try to run here. So there are a couple of other stuff that are great to be learned from Firebase ML kit, but we won't cover them for today. But if you guys want to venture into machine learning for data analytics or machine learning for any other aspect that you want into your application, maybe detect whatever content users are uploading on your applications. If you want to create an embedded system like for our site where we do create maybe a simple robot that will be able to capture images of objects and be able to detect what it is, you should be able to do that using the ML kit. So all these stuffs are into the documentation, into the Firebase documentation. So you go there and then platform, and then down there we have Firebase ML. So when you click on that, you find every aspect that you talked about. So you can see you can use a custom model, you can deploy and manage, then you can migrate from the legacy API. And then you can also train the image labeling models, label your models, then you train detection models. So if you want to learn that advanced way of doing machine learning, you could go through it. And also Python by itself supports machine learning. So you want to maybe create your custom models and deploy them to any other platform that you'll be comfortable with. So everything is highlighted there. You could learn more about it and try to understand the basics, the concepts. Once you run this, maybe to recognize some text into your application, you will be able to run the rest of the APIs that are there, like labeling, recognize the landmarks, labeling items, and and also trying to do analytics based on your machine learning models. So as we wait for this to the build to finish, uh, so this detector object that you created over here is just an instance of the Firebase vision, which now tells Firebase I want to get information from the image that is of vision text detector type. You remember earlier on to our project where we were creating the manifest, we explicitly defined our meta tags to tell Firebase like exactly what do we want to get from the ML kit, and we said we want to get text, face, and label. So for now we're using text, and that's why in our main activity we were able to use vision text detector, which is an instance of the machine learning model. So and then in here we were inside the image text, we were just creating an object, for Firebase machine learning model to be able to predict or to come up with an analysis of your image and be able to come up with text on it. It has to create its own object in which now it can understand better. It's like a layer. So the first layer is your object, and then the second layer is where now Firebase ML kit tries to cover up your object, and then tries to put it in a way in which Firebase ML kit could understand. So using the instance of the detector object up there, you are able to detect, and then it being converted to a bitmap, it will be possible to go through every aspect of the image and be able to tell which line are we going through. So then we created a dummy variable over here. So when you go through every block of instance through our image, we'll be able to get the detected text, and then we just append to the previous one. And then after that, we run the UI. So yes, I think as we be waiting for this build to finish, maybe you guys have some questions on it. This is just a simple implementation of it, but if we have more sessions, the Android 254 will be covering more like the face, labeling objects, and detecting landmarks. Landmarks are like when you take a photograph, or rather when you move around with your camera, with your phone, you'll be able to tell this is a screen, this is a phone, this is. So it tells that because it studies the landmarks of the objects that are in the surrounding. So with time, we'll be able to learn this and understand how to map these objects, try to create a pattern out of an existing object, and then be able to also come up with accurate information. For instance, if today you wanted to create your own virtual tape measure or a ruler, you'll have to have several objects, train it like normally, how do you measure a distance of an object? And then how do you also try to analyze the information based on different scales to come up with an accurate information that you'll be able to measure your object. And also, machine learning does not stop here. Machine learning applies to every aspect, whether web, app, or any other platform that you guys will want to venture into. So it's an interesting field to try out. Do not just use it for image text recognition, but you can also use it to have your data analyzed. You can also have your repetitive tasks analyzed, and they can also be automated. For those who want to go deeper into it, we could also go into Python, NumPy, Keras, and any other way. Using different algorithms, you'll be able to create your own models and be able to predict them. So yeah, so my app just ran. So let me just try to share. Sorry, we just forgot to add the options in the XML to tell our image, our edit text, like we need to get the done action from the keyboard. So let's just correct that. So we just add the im options attribute so that we'll be able to. So we just say im options, then action done. So with this, you'll be able to get the input from the keyboard so that when you hit on done, you'll be able to load the image correctly. So you guys can also do explore more and try to come up with innovative solutions for this, and just try one before. Right now Firebase ML kit has been growing for quite some time, and right now Google and the team are trying to modularize the API to make sure that we have the online ML kit and the offline ML kit work as separately as possible to enable people to be able to detect and do analyze their local storage objects, so that they make sure we can study our objects locally and be able to predict locally, be able to make sure that we are able to detect the images on our objects. And then also, this doesn't choose the platform. I just saw somebody ask if it works with Java. Yeah, it works with Java as well. So the documentation initially was made in Java, so you can still do Java, and yeah, it still works with Kotlin and any other platform that Google owns, because they're really trying as much as possible to make sure all the developers of the stack can be able to achieve the same result. So yeah, unless there's anyone with a question, we'll be running out to see the demo. So you can see the kit has some little code, not too much of a hassle. That doesn't need too much code for you to be able to run. So I just did this a simple one, so you could create a cloud-based service to enable you perform this. Use cases might be maybe detecting explicit content from users' inputs and be able to filter out the information.
Salcie, we have a question on the chat.
Okay, sure. Let me check on. Okay, so currently the minimum supported SDK is 16, but they also support from Android, the Jelly Bean. They also support from Jelly Bean, but it's not like doesn't have for example, if you wanted to have a local model onto your phone, you'll have to have the Google Play services, and from 14 and below, the Google Play services do not support on-device cloud model download. So from 16, I think will work better for you. Though for me, I have worked with 16 and above, and they're working on correctly. I saw someone also asked a question. Let me see. Okay, so I got, can see got a couple of questions. Okay, so someone says, can it work offline? Seen a talk on working with Firebase offline now. So I was wondering. Yeah, you can still work with this offline, and that's why they are trying to modularize it to make sure that we have the offline model working and the online model working. The bad thing about the offline model is that you'll have to first of all, when a person downloads from Play Store or any of your platforms, they'll have to download it locally and then be able to be detected offline. And so you have to, if you are working on a very huge model, you have to worry about memory size and be able to take that into consideration as well, because a model in itself, it needs larger and larger sets of data. So for you to detect in a larger set of data, you just need a bigger space for the model. And then now the model can be able to train and be able to detect into an image itself. Then, yeah, so it can work for offline, that's possible. Then do I need to pay to use it offline like the way it is for online? So Google allows you to use the model offline, but if you want to do a trial, they give you free $300 for Blaze option, and then afterwards you'll be billed for some requests that you make. You make several, just like normally like Firebase, if you hit the threshold that has been calibrated or set, you won't be able to run it unless you pay. Okay. Then we have Washita. And also, how successful is it? Like, detect a book as a book and not as a paper. Don't know if my question makes sense. Yeah, it makes some sense. Yeah, so the only true way to hack this will be to train your own model, so that when you have a set of information, you'll be able to use your own algorithm to make sure that you are detecting objects correctly. But if you're using Google's online cloud API, you will be able to detect approximately 80% of the objects, because the test that we are to perform right now, you will see that some text won't be detected as it is on the image. It will be taken either as a small letter or a capital letter, so it really doesn't know whether this is a small or it's a capital letter. So, but the good thing is, when you're a developer, you will try as much as possible to custom make your program to overcome some of such of these challenges. Then, what's the success rate at detecting offensive material, and how will you personally work at filtering out? One advice I will tell you guys is you do not rely on the model that is online only, because Google ideally will take photos of several objects and try to source the information from all the other sources they're using with scrapping, and then they will be able to tell. And also, they are custom made or deployed models that are already on the cloud. They will be able to detect and tell that this is an object, or if it's an object, what does it contain? And if you want to train also your model to be able to tell whether it's an explicit content, then you have to feed it with lots and lots of information to be able to tell. So the only way to make this thing be more accurate is to have as many data sets as possible. So if you wanted to detect if an animal is a dog, then you give it thousands and thousands of different types of dogs, so that when you give it a dog, it will study out its landmarks and be able to tell, like, this is a dog, and this dog is this type kind, and this is the breed. So if you want your model to be so much accurate, you have to feed it with lots and lots of information so that it's more accurate. So it's all dependent on you. And yeah, so if you want to be a success in this field, then you have to supply the very the very largest set of data, and also your algorithm. So we usually have the linear regression and stuff like that. But for Firebase ML Kit, you're tied to using whatever they already have, but they also give you a way in which you can upload your custom model to the Firebase and be able to detect. The other question is, so if it's offline, they still count how many times I used it past the 300, no more freebies. Okay. For this, for the $300, it will last. Because for me, I have been using the Blaze one, and it's still working for a very long time right now. And after that, you pass the threshold, and once, for instance, you have the offline model, you will be charged at some point, because you will need people to download these models offline, and these are requests, and they will be billed as well. So once a certain threshold is reached, then you'll be able to build and have to subscribe it annually. So you can also check from the link I sent earlier and on the Google Cloud platform, where they have the pricings and any other things that you guys might be interested to see. Yeah, so you know why. Okay. Okay, fine. I forgot to add something over here. So after we have detected our model, we need to close the detector so that we free up on the memory leakage. So we say detector dot close, and then we say true. So if you want to venture into this, we'll advise to first of all explain. Sorry, if you want to venture into the machine learning for mobile, I will advise you to first of all try to do smaller projects. Then once you're very comfortable with this, then you can go to production and be able to do now on larger sets. This thing has a bigger feature, and if you're an Android developer, you want to try out on it so that you'll be able to fast track your users without necessarily being there, so that you'll be able, for instance, if you wanted to create a mobile banking application and you want to detect if maybe you're requesting a user to enter their info and you want an ID, the national ID being uploaded to the user profile. So how will you tell if the user uploaded a user ID, the image of a user, the image, the real actual image of a national ID? So one might just come from the bush and then try to upload the image of a dog. And then you, as of now, you do not have a mandate to tell if the user uploaded the correct image unless you check the DB. So one hack will be to use machine learning. So you would train out the aspects, train out this machine learning model on the aspects of an ID. Tell it like an ID must contain this. It must be having both sides, the front and the back. And how does the front look like? How does the back look like? You train it like you train it all the aspects of an ID, and then you'll be able to allow users to upload. So in case the app finds that this doesn't look like a real national ID, then the users the photo that they did upload will be rejected. So that's one simple case that you can use the machine learning, and it's quite interesting to venture into. And yeah, you guys should definitely try it out. So I have some couple of questions there. So if you don't mind explaining more on what you do. Interesting. Sorry, Magdalene, I didn't get you on what I do in terms of career or in terms of machine learning. Oh, okay. So what I do career-wise, as an systems and embedded Android developer, mine is to create solutions which are software-based and they interface with hardware. So you like create a mobile app that will be communicating with a microcontroller elsewhere to be able to detect maybe collect parameters from a farm or collect parameters from the physical presence and be able to log them onto your application. So you, for example, want to control your lights, maybe your machinery using your mobile app, using either Bluetooth or internet. And yeah, that's what you do most of the time. And then is there need to have a deep knowledge regarding neural networks, machine learning, or model optimization to implement machine learning kit? No, not really. If your intention is just to create simple models and be able to run them locally, then you do not need to learn too much of the neural networks and maybe the algorithms that are entailed behind the scenes, because ideally what machine learning kit has done for you is to abstract all the technical aspects of machine learning from the normal user and just deliver whatever you guys can understand and be able to tell if a model works or not without you having to train or use the linear regression equations that are normally used within machine learning in itself. So if your use case doesn't really need too much of a engagement, like having to code custom algorithm for you to be able to detect or go through the object and ideally make some informative decisions from it, then you do not need to learn the neural networks and stuff like those. But if you're planning to be a master in this field, then you can go ahead and learn Python. It really won't cost you, but it would be a great way to be more better than any other developer outside there. So yes, you can, if your use case is just to make simple programs, for instance, whatever we're doing right now, it's fine. But then you can, if you want in future to become a professional developer in machine learning, then you'll want to learn even the more technical bits of machine learning. Yeah. Unless there's any other question on the chat. Okay, so we have one here. Okay. That. Okay. So answering this other question, if you are to create your own model, say TF Lite, how much data will you need for a fairly accurate model? Okay, so the data is purely dependent on you with the accuracy and the accuracy level that you need. So, for instance, there is this campaign site that normally asks people to upload videos and pictures of them with different objects. So for minimum of, let's say, 10 pictures, you get approximately 40% accuracy if you have like 10 pictures, and the object that you want to detect closely resembles the ones that you already have in your model. So you have at least 40% accuracy. So if you go to 100 more pictures, you'll go to around 60. And if with more and more and more, you get your accuracy more and more. So if you want more accuracy on an item, for instance, if today we wanted to detect if a person is a guy or he's a female. So that's quite pretty simple to detect, because you might train your model to look at the physical attributes and appearance of a person and try to tell that a man looks like this and a lady looks like this. And so for me to differentiate between a guy and a lady, I need to look at this aspect. So some aspects don't require too much data sets. So you just require little information and then you'll be able to detect. But now, if you want, for example, to go further and tell, this is a guy, but I want to tell exactly how does he look, what are the looks, this texture, skin color, and stuff like those. How do I tell that the other attributes? That's when you go further deep and train your model and tell it that if I want this type of guy, maybe he's African, he's European, this is how I go about, and this is how I'll tell. So yeah, that's how we go about it. Let me just try to fix it. I think there's a bug. Yeah, sorry guys. Forgot to add the button to detect the text. Sorry about that. So that. Okay, so let's hope this will at least close up the session. So if there's anyone who still has a question, maybe you can just drop it in there. Yeah, so for our side at Brainverse,
Can anyone still hear Ben, or is it my end only?
I think he dropped out.
Okay. So let's just give him a couple of minutes, and maybe in case he doesn't rejoin, we'll proceed to the second session of the day. Yes, I think he's back.
Sorry guys, dropped off a bit. So since I'm having an issue, running my emulator at the same time. So I'll just take a screenshot of the app running, and then you guys will be able to see what I meant. So okay. So I have an image URL, and let me just capture so that you guys can be able to see. I have an image that that is located on a server somewhere, and then once I click on done my keyboard, you guys will be able to see that Picasso loads, and then the image is displayed on the image. Yeah. This is something that can help you guys see. So I have that. So I just type in the URL, and this is the simple app we're creating right now. And we have our button there to detect the text. So as you can see, this image has the image there, and then there's some text in there. So what we want to do is to use the Firebase machine learning model to try and detect the text that is present in the image. So I'll just press the detect and then recapture text. So yeah, so I did that. So let me just recapture so that you guys can be able to see. Yeah, there we go. So you can see detected text, and then it found Ben Salcie. So I'll try with the second.
Are you sharing something? We can't see your screen.
Oh, sorry, man. Fine, let me just search again. You can enable me to share the screen.
Yeah, let me do so.
Okay, guys, sorry for that. I thought you guys were seeing that. Yeah, so what I'm going to do is just to recapture. Just drop that out. So since I'm having trouble to share my emulator with you guys, because when I try to share my emulator, everything goes off. So I'll just take up a screenshot of the app running. So I have an image, I have a URL, and then an image there. So what I'll do is just hit done on my keyboard, and then the image will load from Picasso. I'll just take the screenshot so that you guys can be able to see. So there we go. So this is a simple app we created. And then I have the URL pasted there, just typed in manually. And then this is the image that I have. So we need to go through the image and see if there's some text present in it. So for this, you can be able to see, but for a bigger image that has several text objects, then you'll be able not to see them at once. So, but with machine learning, you'll be able to detect them. So I just go ahead and click on detect text, then recapture the screen. Yeah, so there we go. You can see detected text is Ben Salcie. So I'll go out and try another image. Okay. So there we go. Let me capture and then you see. So we have that. So I want you guys to know the accuracy of this, because this is a distorted image, and therefore might be confusing to Firebase machine learning kit, and you can see some accuracy effects. And let me try to hit detect so that you guys can see that. So you see the detected text is cell, then it added AL. So to mean the accuracy level for this image was around there 60 to 50%. So you can see it added AL, which is not present there. So we'll try out with another image. I'm just trying to change the numbers because the images I tried to upload them on a server in a way that can be easy to detect. So we have that image. It contains IEEE, Moi University student branch. So we just want to see how much information can it extract from that. So I'll go ahead and hit detect text, then capture that. So there we go. So at least accuracy for this one is around 80% there. So you can see IEEE, Moi University student branch, but it left out the IEEE, the one that is on top. So okay, let's try out with another one.
Salcie?
Yes.
I think you should also be wrapping up so that
Okay.
we can make time for the next speaker.
Okay, fine. So let's try the last one. Just recapture that and then. So I think guys we'll have our session ending there because I can see my PC started to freeze. So, but I hope you guys saw the concept and will be able to implement further on it, build up on it, and be able to build up solutions on the same and try to overcome some of the challenges that Android developers face the machine learning way. So thank you guys for having me, and I appreciate so much for this opportunity. And the source code for this will be shared, and we'll be able to know more and try to explore more. So thank you guys, and have a great one.
So thank you so much, Salcie, for the amazing presentation and the insight about machine learning. Yeah, it's a pleasure to have you. I think you did well on the presentation and also the live coding bit. It was more even interesting. And also thank you for maybe answering all the questions. And we'll keep in touch so that maybe you can plan, maybe build up sessions for on top of these ones. Maybe this was a bit of high level. Then, as you said, we have a lot of things we can cover on the mail kit. So we'll keep on having more sessions of the same type. Yeah, so for those, maybe I'll share his maybe Twitter handle so that maybe you can follow him. And maybe in case you have follow-up question, that is, I've shared on chat. So yeah, thank you, Salcie, for the presentation, and thank you to all those who are asking the question. I think the session was very interactive. So I think the next presentation, I don't want to preempt anything. So I'll let the speaker introduce himself and maybe pick up from there. Oliver, it's your turn now.
Good afternoon, everyone. I hope you can hear me. Am I audible?
Yes, we can hear you.
Okay. So I'm going to walk you through Jetpack Compose. I'll start by sharing my screen. Just a moment.
I think you should be able to share your screen.
Kindly allow me to leave the meeting and rejoin so that I can be able to share my desktop.
All right. So for maybe those who were not present as I was introducing, I've shared a speaker submission link. So in case you'll want to give a session like Salcie did, feel free to do your submission there, and we'll pick it up from there. And we are open to any sessions on Android and Kotlin. I think. Yeah, and in case you have never presented before, we can also assist on that, or maybe have you co-present with someone else.
Hello, Aaron. I'm back again.
Yeah, let me give you permissions. I think you should be able to share your screen now. Yes, we can see your screen.
Okay, thank you so much. So I'll begin by, I've prepared a small presentation. So I'll begin by going through it and introducing myself, and then later on we can go through a small demo. I'd planned for us to do some live coding, but apparently we are working with UI, and we all know how that can end up. So I've prepared something. After the presentation, we're going to go through the application and try to see how much you can grasp from this. So I'll start by introducing myself. My name is Oliver Muthomi. I'm quite fascinated by technology, specifically software development. At the moment, I work at Safaricom as a software engineer. On the side, I love mobile, so I like to do mobile as well, but mostly all my programming on mobile is limited to, say, a hobby, sort of. I haven't done Android programming or uh, any mobile domain in that case professionally, but I'm quite interested in some. So I'm going to go ahead and start by introducing Jetpack Compose. So for anyone that does not know, Jetpack Compose is one of the formerly architecture components introduced by Google a while ago. It's a toolkit for building user interfaces for mobile. So if you want to build the user interface for Android natively, you have two options at the moment. You can decide to go for the old view system, that is the XML layout. At the same time, you can build your own custom Java or Kotlin UI classes and utilize them, which is not quite practical. And then you have Jetpack Compose, which is the new kid in town. It's quite interesting, especially if you are fascinated by UI development. So without further ado, I'm going to go ahead and review some of the advantages Jetpack Compose has over the old view system. So first of all, when you write Jetpack Compose, you write way much lesser code than you would with the traditional layouts. We're going to go through these and see the amount of savings you do. This means you will have an easier time reviewing your code base. You'll have way more visibility about the system, so you'll be able to identify bugs and fix them. So when you use Jetpack Compose, you eliminate a lot of components that are in the old view system. For example, if you wanted to use the tab layout on XML, you'd have to write an adapter for it and say, for example, merge it to a view page or something like that. If you decided to do a recycler view, you'd have to do a list adapter, create a view for it for the actual model in XML, then figure out how you marry the two. And then say, for example, you want to build a very complicated UI, you'd have to go with, so for example, you have a lot of moving parts, you'd have to go for coordinator layouts, and then you nest those with constraint layout and so on. So with Jetpack Compose, you'll realize that you write way much lesser code than you did on XML. Something else is Jetpack Compose declarative. This means that all the data that is displayed in your user interface is held at state. And whenever that data changes, all the elements that are displaying that particular data will update automatically. This means you'll avoid any inconsistency between your layouts and whatever your programmatic code is holding. So as I move to the demo, you'll see how much how this comes into the picture. And then you guys, I'm hoping most of you guys write Kotlin and you know how much you can intermarry Kotlin code within your Java code and vice versa. So Jetpack Compose works in the same way. So you can have some of your existing views still in XML and have some other new views, or as you convert the existing views to Compose. You can have the two in the same project working concurrently without any issues. This means you can also utilize activities and fragments in your Compose UI if you choose to. Alternatively, you can choose to go for composables only, which means you wouldn't have to use the traditional fragments. You don't really need a single activity that is launched when the app initiates. And then you build your entire UI on that. So we'll see how to do that as well. Something else is Jetpack Compose is untied from the OS. This means it's totally a UI toolkit. So for example, I believe most of you are using one or another architecture in your applications. So you realize in most of your architectures, you segregate your presentation bits away from your logic and away from your data storage and all that. So Jetpack Compose is entirely abstracted to the presentation layer. This means it doesn't depend on any APIs provided by the underlying Android OS. Say, if most of you can remember, in 2015, when Google released material design with Lollipop, it was very hard to put Lollipop into KitKat and backwards. So this means with Compose, that would be possible because you don't have any abstractions tying the two together. Also, something else, probably if you've heard about the Jetpack Compose, then you know one or two things about JetBrains Compose, which is the Kotlin equivalent for Android. So if you've had the time to browse, to go through Jetpack Compose, you realize it's pretty much similar to Jetpack Compose, to the level that they share some of the namespaces. Still go and write your Compose application for desktop, and you realize you're referencing some elements from the Android X namespace. So that's possible because of the way it's structured. This also means you don't have to write your UI specifically for the traditional Android. You could as well as utilize Jetpack Compose on Kotlin multi-platform project and so on. Something else, Compose is quite powerful is because, first of all, it's written on all the abstractions of Kotlin. So you have all the juicy things from Kotlin. So it's the same language probably you're using to write most of your logic. So you can easily move on to extend all the skills you have on Kotlin to your UI and make very nice abstractions on that. Moving on to gaming, most people still have a problem with gaming the traditional view system. With a material design 2.0, that has become quite easier. But still, I see some people trying to set primary color dark, say to them they are system bars rather than using, say, the system, the status bar color and the navigation bar color. So it's still quite confusing. You have two things that do the same thing. You're still wondering whether you should use a color accent to theme your UI, I mean your application, or a color secondary because they do the same thing, and so on. So with Kotlin, all that is, I mean, with Jetpack Compose, all that is very well tied together. You can theme your applications from the colors, the typography, the shapes, and so on. All the four elements of theming on material design. Something else, writing UI tests for Jetpack Compose is pretty much simple. But sadly, for this demo, I haven't been able to do to write some tests. I did it quite rushed, so I didn't have enough time to do some UI tests. But say, for example, some other time we could go through that. Then let's look at some problems that you might encounter or that might make you feel uncomfortable using Jetpack Compose at the moment. First of all, Jetpack Compose is it's a functional. It's based on a functional programming approach. So all your UI elements are basically functions, normal functions that you'd write for your application logic or anywhere else, annotated with at composable annotation. So this means you might lack the entire flexibility that comes to you from class-based UI systems, such as an activity or a fragment. So specifically, for the period I've been playing around with Compose, I've had an issue with a dependency injection with composables. But there's a way around that. But say, for example, you wanted to write your entire UI in composables only, that could be quite challenging. So you go through the official docs, Google suggests that you lift your state up. So if you are to go with composables all the way without relying on the traditional view components, you'd have to move, say for example, most of the things you inject into your classes normally, you'd have to do them at the fragments and then pass them down to all the fragments that require them. And then something else you should be aware of, Compose is evolving quite rapidly. For example, right now, the latest version is Alpha 12. The previous one before that is Alpha 11, which became obsolete last Saturday. You look at the change log for Alpha 12, you'll realize there have been quite some breaking changes, although that hasn't happened say from Alpha 8 to 11 sharp. But the thing is, Compose is still in alpha and it's evolving quite rapidly. So if you are to build something with Compose, then I'd advise to keep on checking and following up to see new features, to see what features have become deprecated, so that you don't end up with some source code that you wouldn't be able to maintain, say, 2, 3, 4 releases later. Something else, due to the fact that Compose is still in alpha, you'd expect, say, for example, given that Jetpack Compose has a very tight integration with Android X and Material, the material system, you'd expect most of the elements that exist in the view system should already be available, but you realize some elements are missing. For example, right now, you don't have an official view quetzal. And say, for example, if someone had ported a view quetzal library based on, say, Alpha 9, right now it will require an update to work with Alpha 12. Maybe you don't have a grid layout and the entire grid system. Say some material components are also lacking. But the good thing is for most of these components, actually for any custom component you might want to build, it's very easy to do that with Compose because basically Compose, you'd say it's built up of rows and columns. So you can virtually build anything up with these two. Most of the UI elements within Compose that built up this way. So yeah, in the demo we're going to go through, we've implemented a custom view quetzal. So we'll take some time and go through that and see how that goes. And then something else is, say for example, for seasoned guys who have been using the view system and they're quite familiar with the entire thing with all the small tweaks and everything and how to tune performance to, flattening your layouts and all that. When you come to Compose, you don't have to worry about things like flattening your layouts. They don't have any performance cost at all, like they add on the view system. But given the experience you have with the view system, you might end up bringing some of those practices to Jetpack Compose, and then you'll end up the best way to explain this is, so for example, you're very used to Java. If you can remember when Kotlin went more mainstream, you had all these constructs you used to do in Java, and then moving on to Kotlin, most developers are translating Java into Kotlin rather than using Kotlin specific constructs, which are more efficient and much more concise. So for example, a very general example is you'd write a data class like you would in Java, like a ordinary podzo, and then say leverage on Kotlin to use uh, the standardized setters and getters from there. But then you wouldn't realize the full benefits for using Kotlin, such as using the actual data class element offered by Kotlin. So as you move from the view system to Jetpack Compose, you might want to spend some time to learn about Compose, and especially if you don't have any background with declarative UIs, such as say Flutter. This might give you an extra tool that's not really necessary. So I advise you take some time to learn Compose, maybe even go through a little of Flutter, and then you can really grasp Compose as you move on. So at this point, most people are concerned Jetpack Compose is in alpha. It has been in development for the last 3 or so years. So people are wondering, I'm so used to navigation system by now, to Jetpack navigation by now. I'm so used to life cycle. Say I'm very comfortable with live data, say flow and all that. So am I going to lose all these by switching over to Compose? And then say, what about say that library you normally use, say for rounding image views, say for picking for numbers, is it available in Compose? How can I use it? So first of all, to address that, you could utilize your existing libraries in their views, have them retained in the view system, and then you can consume that from Compose, or say incorporate Compose into your view system if you want. But for Jetpack specific libraries, there's quite a few, there's quite a collection. Sadly, I didn't remember to include the link for that in the presentation. But you look around, you'll find some libraries, say for image loading. Some actually, most of them are maintained by the same people that work on Compose. Some of them are maintained by Airbnb and some individual contributors as well. The library is not quite as huge as that of the view system. So it's something you might, so for example, you have something you really critical in your user interfaces, you might want to consider that. Say when time comes to migrate to Compose, say decide to leave that in the old navigation system, I mean in the old view system, as you wait for a more stable solution for that. So some of the popular, say more critical tools one might use in their apps is a navigation. So if you can remember when I said something around dependency injection, if you are to go fully composable and decide I'm not going to use fragments or activities, you could Jetpack Compose has a navigation system in the Android navigation artifact group. So you can include that in your project, and then you'll be able to navigate without using the old system. So if you can see my screen, this is how it works. It's quite similar to what you'd have on, say, React, native React, and say even Compose. I mean, even Flutter has the same approach towards navigation. So you declare all your destinations within an app host element. And then if you wanted to navigate, say from the home screen to the feed screen, in your home screen composable, you don't have to call your nav controller, navigate and pass in the string of that particular destination you want to navigate to. You can even go ahead and pass data across different composables as well. But to keep it simple, we're going to also, if you have a very, say, robust navigation system in your application and you want to include Jetpack Compose there, you don't have to redo everything from scratch. You can use the existing navigation system, the existing fragments you have, and then once you initialize your fragments or your activities, rather than loading up your XML flavor data binding, or whatever way, you can call a composable that will in turn render the UI for you. So something else is a life cycle. So most people are quite invested in, say, architectures like MVVM, Clean, and so on, and they already have a way you structure your applications immediately you start working on them. So life cycle is quite important, especially in this era of reactive streams and reactive data flows. So, and remember also, Jetpack Compose is purely dependent on state. It's declarative, so whatever you hold in your state is whatever is rendered to your users. So if you wanted to go a very simple way to achieve this, so I remember for declarative UI, once something changes, your entire UI tree is recomposed, and any changes that have been made will be updated to the relevant views. So if you wanted to do something very minimal, you can see the first example here. So remember is a keyword in Compose. It holds information, and the information held within this particular construct does not change, and the composable is recomposed. Again, for declarative UIs, normally on the old view system, you'd have to have, say, an edit text in your layout, and then the value entered on that particular edit text would be completely unattached to any logic within your application, not unless you had some sort of data binding in place. So for Compose, this is extreme. You don't have an initial value or an idle value at any particular moment. So say, for example, to implement an edit text in Compose, you'd have to do this. So you have a text field here. You have a value. This is not the initial value. This is the value that is held, that is displayed by that particular element at all times. Then you have a function to mutate that value. So in this case, we've held the value within this memory provisioned by remember here. So we mutate the value here, and that is what is displayed to this particular text field after it's recomposed. So if you want to do something more in the composed way, or say more intermediate, without having to go deeply into the models and all that, you can do this. You can create a, so say for example, you have an application in say MVC or a not so clear architecture. You just annotate your class with a model, and whenever the properties within that class changes, your entire UI will be recomposed with the new values. And then you can decide to go with your models. The last two examples here, this is nothing to do with Compose. This is how you do that in the existing view system. But to initialize your you can actually initialize your view model within a composable using this particular method here. Yeah, so you can actually build a totally safe UI with Compose and a view model without involving fragments and activities. Okay, so some other tools and libraries I might be concerned about. We have theming explained on how you can theme your Compose applications earlier. Recently, as I think 2 or 1 day ago, layout inspection was added for Compose. So you know how you can normally inspect your layouts on XML, see how flat they are and all that. You can do the same for Compose as well. But remember, Compose also offers you a live preview functionality as you write your composables. Compose also comes with some new data structures that you can use in place of say live data. They're much more easier to observe and to update. And yeah, there's also quite a couple of libraries you can use right now, even though it's still in alpha, but you can pretty much build any application in Compose right now. Whenever, if you're interested, you could have a look at the official samples offered by Google. They're available on GitHub and they're very beautiful applications. So you shouldn't feel uncomfortable with Compose at this particular point of time, but then you'd have to invest more to keep up with the changes as the road narrows down to a more stable build. So again, just to pass this out, when you start writing Compose, especially coming from the view system, you might end up paraphrasing your views, which wouldn't yield much value for you. So that advice you take some time, learn Compose, and then you can go ahead and implement that way. That you're going to enjoy more benefits. Something else, say for example, for the view navigation, I mean for the view based system, you couldn't write your recycler view element within the same UI as your recycler view. I don't know if you understand. With Compose, it's pretty easy to do that. So you might end up nesting a lot of functionality within your composables, which might make them look and be more difficult to maintain. So besides that, maybe try if you're looking forward to adopting Compose at this particular point, I'd advise you stay up to date, try and see what's happening. Every few after some time, I'll just try to understand the changes that have happened since the last say time I interacted with Compose, because you might end up using an element that was there in a version, in two versions. I mean, that was decommissioned, saying two versions behind. So with that, I'll first of all walk you through what this particular demo does, and then we can move on to the source code and identify, see how much you can pick from that. So the demo I decided to do for this application was I don't know if you guys are familiar with the DripConK application. This particular application.
Yes.
Okay, so when you try to learn Compose, you'll find most solutions and most guides online will focus on a very small part, or maybe say something around data entry only, or a very narrow a spectrum of Compose, and you might end up wondering and asking yourself, is this all Compose can do? Like, what if I wanted more? What if I wanted, say, a UI with a lot of things going on, like this on here? How do I go ahead and implement that? So for this particular demo, I decided to redo some of the UI for this application in Compose. We'll see how much difference we achieve. We'll see how much less code we use, and so on. But for the demo specifically, I did this particular page and this particular page, because they seem to be the ones having a lot of things going on. There's a list recyclable. It's already implemented here as well, so there's no need to do that as well. And yeah, this is just some text. So this take of the work is in this particular homepage and this particular sessions page. So before we go to the actual application, I'll show you the solution. I've already compiled this. So it's this application here. I decided to do everything as is on the other application with the difference of some icons and all that. So we have this particular page here. I'm sorry, my images can't load right now, but all these placeholders should have some images as well. So you have an equivalent of what would be a recyclable here. And then you have more recyclables nested into that. You have this one for speakers. These are the one for sessions here. You have quite a lot going on here. You have a counter on top here. So if you notice for this particular application, each of these pages has a different toolbar. So let's see how we can do that, how we can achieve that in Compose. So this a little bit different with what is implemented in the actual application. So we have these here. We can switch between them. You have sort of a view page here, each with data for different days. of the events. So like I said earlier, Compose is purely a user interface toolkit. This means you don't have to change the existing implementation of your other layers of the application. But for this particular sample, just to remove extra functionality that's on the other application, we decided to mux the data and keep it as simple as we could, while still showing how much functional the UI can get. So let's start by seeing how to incorporate Compose into a new application. So before we go to the code, I'll switch over to the Android developer website here. And to integrate Compose to your application, first of all, some preliminary checks you can do. Is ensure you're running Kotlin 1.4.21. Also, when you decide to update your Compose version, kindly keep this in check as well. So for example, for this demo, I did it in Alpha 12, and it's not compatible with Kotlin 1.4.21. It's only compatible with Kotlin 1.4.30. So before you move on, you could do some research, which is much easier than having to deal with errors during compilation. And also, something else to note, Compose is backward compatible to, this is KitKatware to version 21. So I'm assuming most of you know how to integrate data binding or view binding to their projects. So for that, you have to set up your compile options to use Java 8. So you have to do the same as well. And then where you have data binding, you have Compose as well. You can have the three if you're using them in sync. And then something else to note is you also need to add these Kotlin options here. So you have to set a GTM target still to Java 8, and then use IR. There's some extension that enables you to work with Compose. And then that's all you need to set up your project. Once you do that, you'll be able to run Compose. So moving on, you also need the actual Compose libraries. You don't need all of them. You could choose the only ones that you require. So this is the first one here, Compose UI. I don't think there's a way around this. And then for tooling, this allows you to have a live preview. As you work on your composables, you're able to see how they change rather than having to run the application to your device or emulate and then observing a small change and then iterating again and so on. So foundation, this is an old something from the old from the old implementations of Compose. So you'll find as Compose keeps on iterating, some things keep changing. So for example, some particular input layout, say was initially in foundation, which means it was say critical, but then with time, say there's a material implementation for the same. So there's no point in maintaining whatever was in the foundation and so on. So you'll need it as well. If you want to support material theming, you also need this. And then something else nice about Compose is with icons. I don't know if you guys do this, and I don't know if it's available in the view system yet. But you know, as if you wanted to use an icon in your application, you'd have to say a material icon. You'd have to go to the material website, download the vector drawable for this one, and then come import it into your project, and then reference it from there using r.drawable.p file. So to compose it's much easier. With here you can do that with these two libraries here. So this offers a limited set of icons. This offers the entire set of material icons provided on material.io with icons. And then something else with the view system, I don't know if this is available in the view system, but if you are to work with, say, live data, and you wanted to observe a particular variable, you'd have to pass in an observer and then say a lambda or a function to react to that. With Compose, you have a single liner for that, which converts live data into state. State is the sort of the basic data structure, or rather the one that's more encouraged for Compose. So you have a way with that, with this particular dependency here. If you use arrays and so on, these for testing. So if you did this, you'd be able to run Compose on the application. So without wasting more of your time, we'll jump to the application and see how we were able to achieve this particular UI. So you'd set up your project as you would normally. Go to presentation mode. Is it visible enough?
Yes, but you want to go to presentation mode?
Yes. But okay, that's fine. That's fine. So you might ask whether is it possible to write an Android app without any XML at all, totally zero XML, say zero troubles, pure Kotlin. Right now, I've tried doing that as much as I can, and I managed to remain with one XML file I couldn't get away with. And this is the manifest file. So these are still exist. So for this particular application, it launches our main activity and we start Compose from there. So before we go ahead, Compose is this is in regards to theming. Compose as a toolkit that is totally unburdened from the UI. Compose does not have visibility over your system, does this one here, the status bar and the navigation bar. So if you wanted to theme these two, you'd have to do it traditionally, as you would with the layouts file. So I'll show you how I've done that. It's pretty basic, but it wouldn't hurt to know. So I have two variations for a dark and a light variant. So I'm using material theming here just to provide a status bar color and an application bar color. And then say these other two and nothing else. So these are the only two bits you can't access for theming from Compose. Everything else, you don't have to set up your primary colors, your secondary colors, and so on. With Compose, but there's no way of getting around this, at least at the moment. If you want to customize this, you have to use the traditional theming style, which means you'd have to have the old material, not the one I just showed you on the developer website, but the other one in your Gradle file, so that you'll be able to access these particular components. Or you can use any other thing you want for that. So other than that, everything else in your application UI is accessible via Compose. You can customize everything and do all that. So I'll just close this. I'll just navigate to an activity and close the manifest. So you come to your activity again. This is what we have in our activity here. You realize you don't have to set up a layout file for your activity. You don't have to do actually anything in your activity. All your activity does is call this function that calls a composable here. Compose app is a composable. So it's nothing to do here. So we'll move on to this particular composable and see what's going on there. Okay, so if you remember the dependency I showed you earlier, the compose tooling, it provides you with this annotation here. So this annotation will preview whatever is active on that screen here, just as you would with traditional XML. You know how you'd be editing XML on one tab and then previewing it on another one. You exactly do that here. It's much more intuitive than what you do with layouts though. By the way, on the main activity, we've not initialized any layout file. And actually, if you look to our resources directory here, we don't have any layout folders. So we don't have any XML at all for layout. So a composable is just a normal function. As you see here, is a normal Kotlin function. You pass in parameters as you would, you manipulate them as you would. The only difference is just say, for example, for coroutines, how you'd use the keyword suspend to convert a normal function to a coroutine. You do the same with compose. But now, for this case, you annotate the actual function with composable. That way, compose identifies it as a UI block. And once it's executed, whatever definitions you have there for UI are displayed. Okay, so these are base navigation points for this application here. So these are normal properties as you would on a normal function, and this is say what is unique to compose. So first of all, as you can see here, we have these are a custom defined theme declaration for this particular project. If we follow these, we can see it's a normal function that wraps material theme. So with material, you normally have 3 ways to customize material design to your liking and your fitting. So you have colors, which is the most common one. Then you have typography. If you want to use custom fonts, custom colors for different typographies and so on. And then you have shapes. Say you want a more rounded UI, which you want sharp edges and so on. You can customize that for shapes for different size of elements. And nowadays is dark theme. Actually, with Compose, it's very easy to come up with dark theme. All you have to do with, variations of theme. So all you have to do is get a flag to switch between different flags, and then you'd have, so for this case, we have a dark variant and a light variant. So to achieve that, all you have to do is declare the two colors of the theming. You say what do you want as a primary color in dark mode, what do you want as a primary color in light mode, and so on. Declare everything, and then supply those values to this material theme plugin. So with Compose, whatever you pass in here can be rendered within that function. Like you would pass a function to another function and have it executed there. So, for example, if you are familiar with Flutter, you know that Flutter is a widget tree. So you customize the widgets and then they are rendered upwards. But for Compose, it's more you define what you want that particular function to do and then have it executed and rendered as you are. So this is how you theme your application. Say just show something on. If you want to theme your shapes, you have 3 shapes you can theme with material design. So you can theme how you want your small elements to look like. For this case, we have them rounded slightly. So for example, that is something like the cards here. They are very slightly rounded. If you were to increase the values, then you'd have different results. Same thing you do with normal material theming, but way much cleaner and easier to do that. So same thing for typography. If you wanted to customize, say your body one element, you'd come here, specify the font family you want, the font weight. If you have an actual font file, you can do all that from here and customize your typography as you want it. And then now, moving on, Compose offers you some pre-built templates, for easily coming up with UIs. Say a scaffold, just a scaffold, same thing you have on Flutter. So if you go to the API definition for this particular element here, you have a couple of parameters received here. So just as a quick explainer, you have a modifier here. So normally you'd have properties on your XML, properties such as width, which you'd set to say match parent or wrap content. Things like same background, things like tint. Say you want to make that particular element clickable. So set something such as is clickable is equal to true. So all that, you do that with modifiers in Compose. So a quick example is just look at not so easy, or we'll arrive at a point we use that. So for this scaffold here, you have some properties. All these properties you can pass with. So for example, you wanted to implement a drawer layout. The side navigation drawer that you swipe and comes out. So in the layout system, you'd have to have a base drawer layout, and then you'd have the actual layout that is shown above that particular drawer layout, and then another layout for the side drawer, and then come and tie all that together in your loads, which would be very not pleasant. With Compose, if you wanted to achieve something, all you'd have to do is utilize this template here. So you pass in a draw content. This is what will be shown on that particular navigation drawer. Set your content within that, and that's all. So you can set up a toggle in your toolbar or whatever other makes you do, but it's accessible by default when you swipe. So that's all you'd have to do. So looking back at how much less code you write with Compose, if you wanted to implement, say, a floating action bar, all you'd have to do is pass in an element for that. Then you have other properties for the same, say shapes, elevation, and all that. So we're not going to go much into that. So the scaffold basically gives us this particular layout here, which we can do without a scaffold, but that would mean implementing it ourselves, which makes no sense. So for this particular scaffold here, you're passing a top bar, you're passing some content for the body, then you're passing a bottom bar. So the bottom bar is whatever is displayed down here. For the top bar, it's the normal toolbar, the normal app bar I mean. And then for the content, it's whatever is displayed within that scaffold, whatever is inside here. Okay, so someone might ask, so how do you implement a bottom bar? No. So some of these components, say for example, a bottom bar is available already within the material system. So we call another function here. So it's a convention, and then you are composable with a small, I mean with a capital letter rather than a normal function. You can choose to do whatever you want, but this is more conventional. So you come to this particular function here, you receive some parameters saying you have, remember when I talked about navigation, for this example, we are purely doing navigation with Compose. So you pass in your nav controller, and any other properties you want. Say for this particular toolbar, it doesn't align to the material definitions as per the design. So from the app here, we can tell that our surface and background color is white, but the toolbar is black. For dark mode, it's different as well. So to achieve that functionality, we have a toggle here that changes the color and passes that to, there's a slotted field for that. Yeah, you have the selected content color, all that. Your properties, all you do is fill them in with some attributes or other composables. So mostly for composables, you pass them as lambda functions mostly. So yeah, we have an entire bottom bar implemented with this particular code. You don't have to set up some code in your XML and the entire navigation for it as well, and then move on to your logic to start tying things up together. This is all you have to do to achieve the end of these. So you pass in the actual elements you want displayed there. We have items here. It's a list of some classes here because they have other properties like the icons, the root, they're tied to the actual root, and the labels here. And then that's all you have to do for a bottom bar. And then for your screens here, you set up your, so for this particular example, we've set up the content here as our main point of navigation. So whenever the content here changes, we update the state elsewhere, and then we can update the toolbar as well. So you'll realize that when you're in the home fragment of this particular toolbar, you go to sessions, you have these are the different toolbar that is tied to this particular implementation of a view page. For the field screen, you also have a different toolbar. So let's see how we manage to achieve that using Compose. So we go back to our starting point here. This scaffold we call a talk bar. This is a function we define ourselves. And then this here is a function, a composable offered by Material Design. All you have to do to set up a pre-built talk bar is pass in a background color. For this case, we're using the background color as the background color to match the app we're referencing to. And then you want one icon on this particular side. So what you'd have as your home icon in your XML toolbar. So it's called the navigation icon here. You could use it for draw navigation and so on. And once you start navigating deeper into your application, you can use it as to control your backstack. And then what you'd have as menus in your XML layout. It's very easy to implement here. All you have to do is you could pass in one action like we have here. For this case, we've passed in just a single action with an icon. If you passed on, say, a list of several icons, this would collapse to an overflow menu, the umbrella kind. You can set up behaviors for that as well. And then at the middle here, we have a title. So remember when I introduced the material icons for Compose? If you wanted to set up a custom icon, say for something here, you'd have to go to the material design website. Say you want to use the material icons, download that particular icon for a particular size as a, say, a drawable, an SVG, whatever way. Find a way to get it to your project and then reference it using the resources and then the drawable ID. For this case, all you have to do is get this particular input from that particular library and then select the variation you want for your icon. Say, for example, you have these variations for material icons. You have a field, outline, rounded, two-tone, and sharp. So for all of them, you have different variations of the icons. So if you want those variations as well, you just reference whatever you want here. So for this case, we want to use a field icon, and then the icon we want to use. So for example, the icon we're using here, this here, account circle, is exactly what you'd find here as account circle. If you came here and search for account circle, this here, it's the exact one. Yeah, we're using the field version for that case. So we look at our UI and we have the same icon here. So it's pretty easy to use icons here with material and compose. And say for a case you want to use a custom icon that isn't offered by material design, that's possible as well, but there's a caveat. So I included some here. Say for example, you go to this application on the home page, you have this icon here. This is what I'm calling a horn here. So this is not available on material, so you have to use a vector drawable implementation for this one. So right now, initially Compose had access to all these XML drawables, that is kutoka the likes of what they call shapes and so on. But right now you can only access vectors. So I believe it's either a change in API or something going on around that. But there's that, or a push maybe to ensuring you use people stop using raptor images for their applications. If you want to load a normal raster, say a PNG, a JPEG, or so on, you can also access that from your drawables folder. This is exactly what we have here, overlaid with the background as is in the design. Now, say for example, you want to do some, yes.
So maybe you should maybe be wrapping up in the next couple of minutes because we are
okay. Okay. So okay, rather than going through that, I'll try and go to parts that I think might be confusing for some people who are trying to start with Compose. So let's find somewhere we are consuming data. Say we look at this particular screen and how we can come up with this screen here. It's the most complex one of this here. So for that, dashboard session screen. So you can see for all the data here, I mean for everything being split here, we managed to do all that in a single file, which is only 150 lines and it's spaced out. So if you had to do this in traditional XML, you'd have much larger footprint. So to achieve this, we have there's our base screen here. Whatever we have tied to our navigation system, it holds everything within here, except the toolbar, which is hosted separately. So for this case, we wanted to have a scenario where you switch to you swipe your layout to a different day, and the toolbar also updates to that particular new day. So the toolbar is also a very totally independent composable from this. So to do that, you need to have some form of shared view model or pass down state from above. So to do that, we passed a view model that holds that particular state here. So these are normal view models. There's nothing to do with Compose here. It's whatever you'd have in your normal code. And then we have a custom. We've built a custom functionality for a view pager since it's not offered within Compose at the moment. And all we do is for these view page of ours, we have a recycler view here. So the equivalence of what you'd have a recycler view with, alongside the views for the children, the actual recycler view and all that is compressed is here. You use a lazy column instead. A lazy column is for the one that scrolls vertically. For one that scrolls horizontally, you'd use a lazy row. So here we have a modifier. This specifies the properties we'd rather specify in the layout file. So we have a max size, fill max size. This is the equivalence of match parent, paddings, and so on. So something else you might find a little hazy on Compose. You don't have margins. You have padding only. So you manipulate padding depending on the execution flow to create a margin or a padding, the inner one or the outer one. And then you pass in your items here. This is a list of sessions stored in the view model. So from here you can see we are not using the normal, we're not observing these as the old normal live data. These are a collection of Firebase Compose, we'll say that. And then the item content is one item of these, how you want these particular items to be included here. So this is what we have here. It's a card that has rows and columns specifying the actual elements as I've listed here. Something else you might want to do is, say, for example, have a header on your recycler view. What is, let's say, column here? If you were to do that with a recycler view, you'd have to merge in some other element and then use a, say, merge adapter to achieve the same. For this case, all you have to do is come here and include a property known as an item. And then within here, you'd call an existing composable. Let's say this one if you want this, or write your own logic for rendering that UI as a header there. You can have a persistent header and so on. If you want to learn more about this, as you say, try to integrate, you can always go to the actual APIs that are provided and figure out what parameters you need for different properties. So these are you need achieve these with this particular few lines here. And then if you want to customize your UI further, you'd have to do all these according to your own liking. So there's no need to go back to the view model backwards for this application, since Compose specializes on UI. So I don't know if you have any clarifications I might make before I run out of time, or any questions regarding this. Okay, so I'll switch back to the presentation here. So you want to set up Compose, you want to keep up with the development of Compose. How do you achieve that? So the application I just walked you through. This is the link here. I've just hosted it to. I've just committed it to GitHub. If you want to have a look, you can go through the application here. It's quite, if you're trying to come up with a structure for Compose without going to the official Compose samples, which are quite overwhelming, especially for someone who's coming afresh to Compose. You can have a look at it. If you need any clarifications, I'd help. But then if you want to come up with more complex UIs, some fancy animations, custom components, actually the view pager or the custom view pager we're using in the application here is based on an inspiration from one of these ones here. I think Jetcaster. Yeah, Jetcaster. So you might go through these ones as well to come up to figure out how to get Compose running for your application. And then there's a tutorial by a guy called Muthomi. I don't know how many of you are familiar with him. He made really nice tutorials for programming, specifically for Android. He has a whole series of videos on YouTube explaining how to build up a recipe application using Compose. And for our case, for this particular application, we've gone for the entire the Compose navigation system, where we have ignored fragments and all that. For this course here, I mean for these videos here, here's going to be the other alternative. So if you want to see how you can inject dependencies into your composables and all that, you can have a look at that. And then if you want to keep up with what is happening within Compose, you can follow Chris Benz on Twitter. He's one of the guys working on Compose. You can follow Chris Benz, you can follow Leland, and some other guys who work on the actual project to be notified of any breaking changes, to know how to handle some things that might break, although they're very little. Yes. So welcome any questions. I think if you want to have a look of how we achieved that particular UI, you can visit this link here. If you have any clarifications, you can reach me out. My Twitter handle is Muthomi.
So I think if we don't have any other question, I think we'll try to wrap up everything. Do you have any question for Oliver? Okay. So thank you so much, Oliver, for the amazing session on Compose. I like the fact that you discussed the challenges maybe on Compose. I think not many take time to maybe just highlight some of the challenges you might face once you start like adapting Compose. So thank you for that, and also for the demo. I think it's a very comprehensive one that shows how to do all the complex things, maybe from network calls, view models, lifecycle, and also view pages in your application. Thank you so much. And I think maybe we should plan for maybe another session where you maybe build upon what you have just maybe explained right now, because I think we need even much more time.
Okay.
Yeah. So thank you so much. And also to all the attendees, I want to take this chance to maybe appreciate you. Yes, it's one thing to plan for a meetup, and it's another thing for people to attend. So thank you so much. You've made this happen. And for our speakers today, thank you so Ben and Oliver. We appreciate you so much. And yeah, feel free to maybe pick up another slot and maybe build upon what you've maybe just started here. And for the attendees, I've shared all the Twitter handles for the speakers. So in case you want to maybe reach out to them for follow-up questions and so on, feel free to reach out on them. So from my side, I think that's all. In case you also want to maybe reach out, maybe we are on Telegram, maybe you can just drop us a message there, Android 254 or Kotlin Kenya, or let me share my Twitter handle just in case you'll want to ask anything or maybe something of the sort. Yes, so I've shared. And that signifies the end of our meetup today. See you next month on the third Saturday, and we'll keep on updating you guys. Thank you so much for attending.
It's been my pleasure. Thank you.
Okay.